with statistics. Today we're going to talk about the 5-number summary, which actually creates for us a box plot, or what can be also called as a box and whisker plot. So quantitative data, data with numbers, can be divided into 4 equal parts called quartiles. Chloe, will you do me a favor? Go open my Google Chrome and shut off Pandora, or close Pandora. Far left one, yep. Yeah, that's totally fine. Perfect, thank you. So today you're going to focus on the 5-number summary. 5-number summary includes the minimum, the first quartile, the median, the third quartile, and the maximum. 5 things. The 5-number summary creates a box plot, and it's a way for us to visualize data. Notice how many dots are on the box plot? 5. So guess what those 5 are? Starting on the left, this is your min. This is your, what I call Q1, quartile 1. This is your median. This is your Q3, and this is your max. Now, the other 2 are just labeling the fact that this is called a whisker, and this is called the box. Okay? So if you notice, between those points, we have 4 different sections, yes? Those are your 4 quartiles. So those 5 points create 4 chunks. And every single one of those chunks contains 25% of your data. There's 25% there, there's 25% here, there's 25% here, and there's 25% here. So the quartiles are all split up 25%, 25%, 25%, 25%. I will tell you, this is easiest done by immediately putting your numbers in order from least to greatest. Going to point out your minimum, it's going to point out your maximum, and your median's easy to find. So the data for daily average temperatures for 15 days in May are shown in the table. Find the 5-number summary, so we're going to have 5 answers there. Create the box and whisker plot, and calculate the interquartile range. So the first thing we should do is list these numbers in order. What's your smallest number in that table? 68 is? So 68. 69, 70, 71, 72. There's 2 of those, good. 73, 74. 1, 2, 3, 4 times. 1, 2, 3, 4 times, and then 3 76s. And so I've sucked at spacing this out. Three 76s? Okay, so then what I usually do is list my 5-number summary vertically. Minimum, Q1, median, Q3, and your max. And now that your numbers are in order, it's actually super simple. What's your minimum? 68. What's your maximum? 76. How do I find the median? Highs, lows, highs, lows. Now, here's the deal. We're going to have to use these numbers again. So I would do something like just underlining them so that you can still read the numbers. I fall right on 74. You did too? Now, because you fall right on 74, 74 does not belong to the lower half, and it does not belong to the upper half. Because look here, 1, 2, 3, 4, 5, 6, 7 numbers below, 1, 2, 3, 4, 5, 6, 7 numbers above. Your median should always split it into 2 equal parts. Does that make sense? Now, your Q1 occurs in the middle of the lower half. So we're going to reuse these numbers, and we need to find the middle of these numbers. And that's why I say don't cross them off where you can't read them. So now I have 68 and 73, 69 and 72, 70 and 72. So your Q1 is actually 71. And if you do the same thing on the upper half, what do you get for Q3? 75. Now look for a second here. 3 numbers, then your Q1. 3 numbers, your median. 3 numbers, your Q3. 3 numbers. That should happen every time because it's 25%. Okay, so now we have to plot these. You put 5 dots, not on the number line. Notice the number, they're above the number line. So we want to put 5 dots at these 5 number summaries. So 68, 71, 74, 75, 76. The whiskers occur on the outside. So your min and your max draw a whisker in. Then your inside 3 dots have a rectangle on them. And then slice it through that. Ooh, that's a terrible slice. Slice it through here. Now the nice part is this is on Alex. So the box and whisker plot's already there. You literally just have to drag the dots to the right numbers. It's kind of nice, actually. Here's my question. If there's 25% here, and there's 25% here, and there's 25% here, and there's 25% here, why aren't they the same size? Emily?
Because some numbers are specific.
Okay, and what does that cause the box and whisker plot to do then?
It causes it to get smaller because you're not, like, you can't list it more than what's on the box.
Okay. She's on to something. Anything you want to add to that? Riley?
Like it's bigger range.
Bingo. And that's ultimately what happens too. You have 25% of your data. Well, if they're repeat numbers, they're not as spread out, right? And so that's your range. So if you think about this, if you have a really long whisker or a really long box, what's that tell you about the data in that 25%? It's really spread out. There's more variance in it, yes? Versus if it's really close together or really small, that means there's probably a repeated number, obviously depending on the scale on the bottom. Then it asks us to find the inner quartile range, which is shortcut for IQR. IQR is calculated by taking Q3 minus Q1. Q3 is 75. Q1 is 75 minus 71, 4. Your inner quartile range is 4. Have you done these before? You have? Okay. All right. On the back, let's just analyze them. 2 athletes are training for a cycling race. Each athlete recorded the distance of their in miles of their previous 95 training rides. The box and whisker plots below summarize the distance recorded for each athlete. Use the box and whisker plot to answer the question. Which athlete had a greater median distance? Athlete A. Median is the line in the middle of the big rectangle. Which athlete had distances with a larger inner quartile range?
No, B. It's like the numbers are close together.
What's IQR? How do you calculate that? Q3 minus Q1. Okay, so for athlete A, what's Q3? I'd say 40. I would say 40 minus 25. Is that what you said? Which is 15. Athlete B, 37 minus 29, which is 8. So who has a larger interquartile range? Is there another way I could have figured that out? Bingo. If you're quartile 1 and 3, they're on the same scale, right? Which one has the furthest distance between Q1 and Q3? Which athlete had a smaller range of distances? What's range again? Max minus your min. It's way shorter, yes. Way smaller, so yes, B. Which athlete went on the shortest training ride? You're talking about your mins, right? Who has the smallest min? Minimum here is 20. Minimum here is 26. I would say athlete A.
So athlete B ran farther?
Not necessarily.
Actually,
You don't know all the data points in there. You don't know their total amounts. These are just like, on day 1, they went this many miles. On day 2, they went this many miles, and they put them in a row. I am out of paper with the grids on it. So you will have to use your own paper or anything that I have back there. That's fine. Okay, I just don't have anything with the boxes in it. All right, go to it.